So yesterday you guys did law of cosines, which is basically a formula where you could use cosine to find sides and angles of non-right triangles. There's also something called the law of sines, where you can find sides and angles of non-right angles based on given information. And you have this law right up here of sines, where it is basically the numerator is the sine of an angle, and then the denominator is the side opposite of it. So the sine of A will equal the sine of B over B, and the sine of C over C. Okay, of course, when we go to solve something, we only do two of those ratios to set up a proportion in order to solve. But since there's three sides and three angles, any of those two out of the three could be set equal to each other. And then the one right next to it just basically does the reciprocal of everything. And basically, if you want to find an angle, you would put the angle on top. You'd put sine of A over A, sine of B over B, sine of C over C. If you were trying to find a side length, you would put the side length in the numerator, and you do A over the sine of A, B over the sine of B, and C over the sine of C. Key thing to make sure you remember is that when you're using this formula, it's A over the sine of the angle. It's not A over the angle measure. So just be careful with that. And you can use the law of sines if you have angle, angle, side, angle, or side, side, angle. And so basically, in order to use the law of sines, you need to be given an angle and the side opposite of it, or be able to figure that out. Okay, so some helpful hints. You're going to be setting up proportions, basically. So you're going to be setting up a proportion. One side of the proportion is going to be, you need to have that side and angle opposite of each other given to you. And then the other side, you'll have one of them given to you, and the other one is a piece of missing information. And then when you're setting up the equation, as you kind of learned when you did trig functions before, when the variable, the unknown, is in the numerator, it's a lot easier to solve. It's like one step. You're just multiplying both sides by whatever's in the denominator. So anytime you're setting up these proportions, we always want to put the missing piece of information in the numerator. It just makes the algebra easier. Okay, so let's actually see how this works. So we have a triangle here. We are given 107 degrees, 25 degrees, and we are given one side this 15 degrees. And basically it wants us to find the rest of the information that we're missing. Okay, whenever we are going to use the law of sines, we always want to make sure that we have a side and an angle opposite of it. So 25 and 15, 25 degrees and 15 are opposite of each other, which means those are going to be one side of your proportion. But let's go ahead and just start with something a little bit easier first. So if we need to figure out what angle A is, which is here our top question, angle A, we can just use triangle sum. And if we use triangle sum, 107 and 25 subtracted from 180 is 48 degrees. So let's start nice and simple. We've done that 1,000 times before. Now we want to find side C. Okay, so side C is opposite. Oops. Is opposite of the 107 degree angle. Okay, so in order to set up our proportion, we are going to use the two known, what I have highlighted in gray. Those are what we know for sure. And then the pink is what we are actually trying to find. And remember, our helpful hint from the last slide said whatever the unknown is, we want to put that in the numerator to make our algebra a little simpler. So our one side of the proportion is always what we know. And we're trying to find a side. So since we're finding a side, we're going to put the side in the numerator. Okay, so that means, right, my known information in gray, I have the side length of 15 over the sine of 25. Okay, that's what we had highlighted in gray. And then equals, well, we're trying to find C, so what we had highlighted in pink is C over the sine of 107. So that was what we had highlighted. Oh, gosh darn it. I wanted to highlight. I did not want to That is what we had highlighted in pink. So we know we have the sides on the top, 15 and C, those are both side lengths, and then the angles are in the denominator. So all we really have to do to get C all by itself, some basic algebra, okay, is we could think cross product here, but that makes it a little bit more difficult than it needs to be. Right now, C is being divided by the sine of 107, which means to undo that, we're just going to multiply both sides by the sine of 107. So if we do that, we're going to multiply this side also by the sine of 107. And what we have left with over here, these are going to cancel. We have C all by itself now. Now we just need to make sure we can put this into the calculator correctly. Okay, so go ahead and try it. Put it into your calculator. You're going to need to make sure you have the sine of 107. That's going to be a decimal value multiplied by 15 divided by the sine of 25. Some calculators might need you to put parentheses around that depending on what calculator program you're using or if you're using Desmos. But when you get all of your information entered into the calculator, you should get that C equals 33.9. I want you to practice that and make sure you know how to put that into the calculator. So we have 33.9. Okay. Now we also need to find A. Again, we need to just use that given information. And again, we're finding a side length. So since we're finding a side length, our side lengths are going to be in the numerator. So we're going to use that same 15 over the sine of 25, because that's what we know, equals, now I don't know what A is, but it's across from, remember, angle A we said was 48 degrees, but it is across from a 48-degree angle. So it would be A divided by the sine of 48. Again, all we really have to do to get rid of that A divided by the sine of 48 is we need to multiply both sides by the sine of 48. And our sines of 48 over here are going to cancel. We get A all by itself. And again, you need to practice putting this in your calculator to make sure you can get all the parentheses correct where you need them to be, all the decimals where they need to be, things like that. But if you do it correctly, you should get that A equals 26.4. Okay, the next one, so on those previous examples, we were just finding side lengths. Now we can also use the law of sines to find an angle measure. Okay, so since we are finding an angle measure, we are going to put the angles in the top, in the numerator. Just makes for easier algebra. Okay, so we always want to say, do I have a pair of opposite sides I know? Okay, well I know that 15 and 20 are opposite of each other. They are across, which means that's going to be one side of my proportion. So I'm going to have the sine of 115 over 20. Okay, and again, I'm finding an angle, so I'm going to put my angle in the top. Okay, equals, well I'm trying to find B, right? So I'd say on the other side would be the sine of B over 11, because there we go, kind of right through the middle. The sine of B over the side opposite of it, which is 11. Now, again, all that we really need to do here, I need to undo divided by 11. So I'm going to multiply both sides by 11. And this right here is going to be a decimal value. If you can put it all into your calculator at once, that's fine, and try and do the inverse sign all at the same time. Otherwise, you can put what I have circled in red into your calculator and get a decimal. Okay, if you put that all in correctly, you should get a decimal of 0.4985 equals the sine of B. Okay, usually that 0.4985, we've been thinking about it as a ratio. In this case, any ratio can be written as a decimal. So we're going to go ahead and use that decimal. And in order to find angle B, we just use the inverse sine of that. So we'd do the inverse sine of 0.4985 equals B. And what you should find is that angle B is 29.9 degrees. Okay. What I want you to do is you have 2 more questions. One of them, question 6 here, I want you try it on your own. I want you to find angle C, which is just like the slide that we did a second ago. Come and show it to either me or Miss Valley, and we can check that you're right, help you along if you have anything incorrect in your calculator, anything incorrect in your proportions. But again, keeping in mind we're finding angle C, which means when we set up our proportion, we want to make sure that our angles in the top and our side lengths are in the bottom. I'll kind of help you get set up. So here's what we know. Angle C, so the sine of C over 17 equals the sine, in case the angle is 51. Remember, sine trig functions are always attached to the angle, so it's the sine of 51 over 18. So go ahead and figure that one out. Calculate it out and find the measure of angle C. And then I also want you to go ahead and use this one. I want you to find the length of C. Okay, so it's a surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from the north picnic area to the south picnic area. Find the length of the bridge. Well, the length of the bridge is side C. Okay, so here's our 60 degrees and C are across from each other. And then we need to have an angle and a side matched up across from each other. Right now, there's not, because if you look right now, 71 and A, that we need a matching pair where you have known information. However, if you go the other way, 150 and angle B, we know what angle B is, just triangle sum right there, which means we have a 71 degrees, 60 degrees. Angle B angle B is 49 degrees. Okay, that's just triangle sum right there, which means using the law of sines to find a side length means we're going to put that missing side length in the numerator, C, divided by, well, the angle across from C is 60 degrees, so C divided by the sine of 60 equals, then we need to match it up with a pair of known information. Well, the side length that goes with angle B is 150 divided by the sine of 49. So go ahead, do some solving here and figure out what the length of C is. Remember, the last slide you had to use the inverse sign because you were finding an angle. On this one, you are finding a side length, which means you do not need to use the inverse sign on here. You're finding a side length. So when you're done with this one, go ahead and let Miss Valley or I see it so we can help you with any misconceptions or misunderstandings you might have. Good luck.